Hey guys, welcome to the Skolo Online YouTube channel, the channel that is all about learning. Okay, in this channel, we cover everything from web development, Python programming, all the way to e-commerce development, and anything that I come across that I find interesting that I feel that you guys might learn from. Okay, so last week we did this video on a very quick introduction into OpenAI API, and I talked, I think, for like 5 minutes about Web 3.0. I'm gonna try and expand on this in this video today because I don't think I did it quite justice from last week's video. But very quickly, if you're new to this channel, remember to like this video, remember to subscribe to the channel so that you'll get notifications every time we publish a new video. And of course, you would have to turn on your notifications for you to be able to do that. All right, at the bottom of the video that you're watching right now, if you just scroll underneath, there will be that button that says show more. Just click on that and it will open up. Okay, so if you hear me saying I'm going to link something in the description below, that's where you're going to find it. All right, and if the video is long enough, I will also put timestamps, video timestamps in there that you can just click on to any part of the video that you want to watch. And if you come back in the future, you can use those timestamps as well to navigate, because you don't actually have to watch the whole video. I know my videos are quite long. You can just skip through the section that you want to watch and start from there. Okay, and we'll have also our social media links, Medium publication, whatever, just go into there and sort of explore and find what's useful to you. All right, so today we're going to expand a little bit on what we started with last week. Okay, so last week we spoke for like 5 minutes around Web 3.0, and I'm going to expand on that today because I'd like to spend a couple of videos, upcoming videos, expanding on this topic, because I think it's very interesting. And if you're going to go into development in this time and in this space, it's probably an area of development that you want to learn, because it's growing quite rapidly and there's a lot of opportunities for new developers to do interesting things in this field. So I'm going to try and cover it as much as possible. Believe it or not, when I first came into programming, my programming journey started with blockchain development. And, for years, that's what I did. Before I even started doing web development, I was doing Web 3.0 and decentralized application development. Very interesting because at the time, it wasn't so popular. And today, everybody's going back into it. And, I have to go and brush up on my notes and brush up on my knowledge. But this is an area that I'm very comfortable with. And perhaps because it's becoming more popular, and we're getting requests from our viewerships to cover some sections in this, I will try and see and try actually to do this video and have you guys leave me comments, because there is so much to cover in this area that you guys are going to have to guide me into specifically what you want to learn. All right, and I'm going to try and give you like a very high level bird's eye view in this video of the entire sort of space, not the entire space, but as much as I feel like I can cover comfortably. And then after that, you guys can comment in the comments below and let me know which section is of more interest to you, because this field, like I said, is actually quite vast. All right, so I'm going to try break it down from the beginning. And so yeah, let's get right into it. Right, so when we talk about a blockchain, right, blockchain, I've done a video on our channel. If you go to our YouTube channel, right, and you navigate to Skolo Online, if you click on this channel over there, right, and you go to our playlists, I don't know if it's under playlists, let's see. If you go to playlists and you go back on the playlists, there should be a playlist on blockchain development, right? I don't see it. All right, where is it? So it's not in the playlists. You'll have to look for it. Let's see. All right, so let's go into videos, right? If you go into videos, you're gonna have to navigate a bit back, because it's quite a long time ago when I did this. If you go all the way back, there it is. All right, so there is this video that says build your own blockchain from scratch using Python. Okay, so this video, there's a lot of interest in it, and some people are like, but you didn't have the whole content. Some of it is on my website, because this is really complex stuff, and of course it's hours and hours of development trying to build your own blockchain from scratch. But in this video specifically, and if you're interested, you can go and watch the whole course content on our website. And also proof of work blockchain, there's another video that's sort of like, it's complements this one. In this video, I spend a lot of time explaining to you the concept of a block and the concept of a blockchain when blocks come together, and we even program a whole block and we go through the transactions, and we go through programming, how to develop your keys, your private keys, your secret keys, and the entire sort of like, algorithm behind, hashing of a block, and doing a lot of the sort of the smart not smart contract, but the sort of the private public secret key combination, and that whole elliptic curve cryptography. So there's a lot of concepts behind how to build a block, and how it all comes together when you're working on a proof of work blockchain specifically. All right, and we cover a lot of that in this video, and I don't think I want to do any more on this, because if you want to learn about how blocks and chains and they all come together, that's the best video for you to go and have a look, because we even write Python code to specifically help you understand how it all comes together, and the information is stored. Okay, so if you can understand that, you at least have the basic concepts of what really is behind this technology, right? So when you move on from there, the next step is to understand what is now a peer-to-peer network. All right, a peer-to-peer network is specifically, we covered that I think in this video when we talk about a proof of work blockchain a little bit. Okay, but I can give you a very high definition. A peer-to-peer network is when you've got block one, block two. Let's say you build these blocks, as I've described them here, all right, and you build thousands and thousands of blocks on top of each other, right? This is like a way of storing information, but you store it in sort of like a ledger format, because you entering information, and as you enter information, it updates what you already had. The blocks that you've entered before, you don't like edit or remove or anything. You just sort of enter new information on top of what is already there. So it's sort of like, think of it as entering information into a ledger. Okay, if you think of a Python program where you might say something like, let me just create a new slide over here, right? A new empty slide, so that I can type something into it, right? If you're writing a Python program, for example, and you say x is equals to 1, right? And then you say y is equals to 2, right? And then you run a program that you say x plus y, right? What is that program? What it will do for you is that it will go and it will add this stuff up, and it will I'm just trying to make this bigger so that you can see it better. Let's format it there, and let's make this a little bit bigger. Let's make it like 50, all right? And let's make it proper black like that. All right. So if you were running a Python program and you said x is equals to 1, y is equals to 2, and you said x plus y is equals to, it will calculate for you what you have stored under the variable x and what you've stored under the variable y. So this is like a storage of sorts, okay, like a but it is like a memory storage. So what it will give you, it will go and look for what is stored in x, what is stored in y, and it will add them up, and it will give you an answer, right? Then you can run another line of code and say x is now equals to 4, and then you can run again x plus y, right? And it will give you a new answer, because you've updated what x is. You've updated the storage of what was inside of x. You've changed it to 4. And when you run this, it will now say 4 plus 2, and then it will give you a different answer, right? That's typically how Python works, but how most databases work as well. A database is like a bucket. You store something inside of that bucket, and you can change what you've stored in there. And once you've changed this, there is no way of you going back and figuring out what x was before. So somebody can change that information, and you'll never know what it was before, because once it's changed, the database only remembers what is currently saved now. All right, and when you run this x plus y, it's going to give you the current answer of x plus 1. But the reason why I'm going into these basics is to help you understand how blockchains work. Blockchains work completely different, as opposed to you can change information in a blockchain, but you can only change it by creating a new block over and above the other blocks. So if you wanted to know what was initially in block 1 or block 2, you can always look it up, and it will always be there. All right, so you enter information in a ledger format. You don't delete what was there before, you just append with a new data. All right, so you will always know what was for example in x before. So if you think about this x plus y, and that you change now X to 4, if it was stored in a blockchain type arrangement database, you would still be able to find what was the original X, even though you know what is the current X. All right, and that's how the majority of blockchains work, and that's what makes them completely different from standard databases. And when we start talking about being able to store even financial information, it's because of these features of a blockchain that is possible. All right, so imagine you have this block 1 up to block 4. All right, and this is kept inside of what we call a node or a computer. Or think of my computer as a server. All right, so my computer can keep this ledger of blocks from block 1 to block X, and it's saved inside of this node. All right, and now I could still, if I really wanted, go into block 1 and change some information in there, and nobody would know, because I would be now interfering even within the architecture of the blockchain. I can go and change things if I really, really wanted. I could, right? I could typically do that. But how a blockchain prevents that from happening is that typically within a proper network of blockchains, you would have more than one peer that is storing the same information, all right? So you would have my node server sitting here that I'm maintaining, and then you have Mr. X is maintaining another node server, Mr. Y, Mr. Z, and there's a lot of these blocks all around distributed in multiple different servers storing the same information, that if I updated anything in my block 1 and tried to change that information, all right, my block 1 will be different from this one's block 1 and from that and that. But perhaps this block 1 and that block 1 and that block 1 will be the same. And this block 1 will be the only one that's different. So when this blockchain when they are constantly confirming that which one is the correct block, they'll be able to vote and say, no, our information is the same, but this one is different, so this one is not like ours, so we're going to discard that information and we're going to vote on these ones are the correct ones. So that's how, typically, very high level, how blockchains work in maintaining consistency of information between the different nodes. All right, and if you think of a blockchain like Bitcoin, for example, there's thousands and thousands, hundreds and thousands of nodes that maintain the same sets of blockchain from the very first initial block that was mined by Satoshi Nakamoto. Okay, all of that from that first block to the current block that is on, and you can go check the block explorer to figure out what block we are on right now. Okay, but there's thousands and thousands and thousands of blocks, and all of that information has been kept constant from the very first block that was mined, and it's all maintained across different nodes across the world that maintain that same information. All right, and that's what makes it different from a typical database, and that's what makes it different from the old traditional way of storing information, in that information is stored across multiple places, the same information, and it's stored in a ledger format, in the sense that when you enter new information, you're not deleting old information, you're just adding on top of the old information, so that you keep adding the chain. And you could argue maybe it's an inefficient way of storing information, because there's a reason why databases work the way they do, because now every time you need to now go and confirm what's the latest blockchain, you have to check all the blocks, every thousands of blocks, you have to go through all of them. This is why blockchains are very data intensive. This is why mining blockchain takes a lot of time and effort and energy, and it costs a lot, because you have to sort of verify across all the blocks to figure out what is the current state of the current state. Okay, so very high level under explanation. When I'm going to cover blockchain development or starting to go into Web 3.0, these are the kind of areas that I could be covering, and perhaps take note, and later on at the end of this video, you let me know if this is what you want me to expand more on in terms of creating new content for the channel. All right, now, when I used to do a lot of blockchain development, even I had a startup in blockchain, and I used to try and I used to attend a lot of these meetings when I try to convince people, tell people what blockchains are, trying to show people the sort of the beauty of it, right? And the question I used to get a lot was, but what is the difference? And as much as I explained this to you, you will still get that question. What is the difference between just storing that information in a database? Like, why can't I just store it in a database? Because I can have a backup of a database, and if I wanted to know what it was before, I could go into the backup, all right? And I could create technically a database that works in a ledger format if I wanted to be able to know what was there before. So why can't I just do that in a typical database? Someone asks you that question. The best way to answer it is a blockchain is a distributed database. All right? It is a database. This is a database. This is one database. This is another database. All right? This is another database. This is another database. And all the nodes that are connected into the chain, into that peer network, are all databases in their own right. Okay? So as opposed, instead of having one single database that has a backup or 100 backups or however many backups you want, right? You have 1,000,000 or 1,000 databases that are storing the same information. That is the difference. Yes, it is a database, but it's not one database. It's 1,000 databases storing the same information. So is that for the sake of backup, so that we'll know what is the correct information stored? No, it's not because of backup. It's because we want to create a trustless system. If you think of a traditional database, whether you're storing your information in AWS or whatever, you have to trust AWS to store information safely, and you have to trust AWS that the information that you've stored in there is the correct information. So there is a single point of failure. If somebody, if the government shut down AWS tomorrow, or for whatever reason, like what happened with the Facebook, blackout that other day, something goes wrong with the servers, there's a single point of failure. All right, if those servers go down for whatever reasons, that information is gone. It's in those servers with their backups. All right, a peer-to-peer network, because I have 1,000 databases, if anything happens to this node, I've got the remaining 999 nodes and databases storing that same information. If anything happens to that node, if in China they ban blockchain, the whole of China, right, I don't care, because I've got nodes in Russia, I've got nodes in the US, I've got nodes in Africa, I've got nodes everywhere that's keeping the same information. This is why it is really, really difficult to completely ban a distributed system like blockchain, because that information exists everywhere. You would have to shut down each and every single node that is maintaining the blockchain for you to shut it down. All right, so that is the difference between a database and a blockchain, is that a blockchain is 1,000 databases storing the same information, and it is censorship proof. All right, and you don't have to trust a single party or a single individual to maintain that data for you, because it is maintained by 1,000 individuals who are able to, through the mathematics of the system, maintain the integrity of the data through the voting process, that we always have the latest version of the correct information maintained. All right, so that's peer-to-peer. All right, let's go into public and enterprise blockchain, because then I would be like going into, but we want to build a blockchain, for example, for the supply chain network or whatever, and they're like, no, but and then you get people that are very pro blockchain that don't understand what is the point of an enterprise blockchain, because it defeats the whole purpose of decentralization, right? So let's discuss this. Let's discuss it, and you can make up your own mind at the end of the day, right? What is the difference between a public blockchain and an enterprise private blockchain? And is an enterprise private blockchain really a blockchain if it's private, right? So let's go into that. A peer-to-peer blockchain, this explains what a public blockchain is. So that's pretty much already covered, all right? Anyone can access. It's an open, it's open, not open source, but it's open. If I had the resources today to run a Bitcoin, node, I could do that. If I wanted to build a node like this for Bitcoin and enter the network and be one of the peers, I could do that. I just need the resources and the mining capabilities to do that. But no one is stopping me. It's an open blockchain. I can do it, and I can maintain my own copy of the Bitcoin blockchain, and I can keep it in my computer if I wanted. Ethereum, all of these public blockchains, you could run your own node if you wanted. All right? That's the first difference. But the challenge with that is that how do you incentivize people to maintain the blockchain? So think about, I don't know how to explain this. Let me find the best way to do this, right? In a private blockchain, right? In a private blockchain, these nodes are resources. These nodes are resources. They're not free, okay? So if you want to run a Bitcoin node, for example, there is a couple of terabytes of space that you need to have in your node. So a typical computer like mine, like a MacBook, would not be able to run a blockchain, a Bitcoin node. You would need a big computer with a lot of, some terabyte of storage space, all right, and then some petabytes of processing capability to be able to process the sort of the mining, the level of mining that's required. Okay, this is why people that want to run rigs like this, they have to go to low energy areas of the world where they can save electricity, because it costs a lot of electricity and actual resources that cost you money, okay, to be able to run a node. So why would you want to do it? Why would you want to run a node if it's going to cost you as much money as it costs to run, for example, something like a blockchain node? All right. The reason why you want to do it, and it's the incentive behind running public blockchains, and it's what has enabled public blockchains to be successful as they are, is the rewards of it. Okay. So the way the public blockchains are designed is that if you run a node and you contribute into the mining, and the mining of the node is actually just maintaining the transactions and helping to maintain the integrity, so being able to contribute your computing power into running the system, okay, you get rewarded by the newly minted cryptocurrency of that chain. So if you're running a blockchain node, a Bitcoin node, you get rewarded every time you create a new block and you participate in the network, and you participate in sort of maintaining the network. You get given new you get to reap, to mine coins. So this is what mining is, all right. And I cover it a bit in this course that I've talked to you about, and you can go and watch it in detail, how the proof of work specifically works with you being able to get new coins minted that you get rewarded in it. And because these coins are traded and they're worth a lot of money, you can go into the exchange and trade them for US dollars or for another coin, and you can make money. So people are still running nodes today because it's profitable to run the nodes, because you get paid in Bitcoins, and then you can go and exchange that for whatever you want to exchange it for. All right. So that's the incentive. That is why people still run the nodes, why people still mine the coin, because there's money to be involved, but to be gained. But in a private type arrangement, usually there is no cryptocurrency behind it, and we're going to get into now how does the incentive structure work, and how do they maintain their the integrity of their coin there, because there's no need for for incentivizing people, because it's private, right? Because of the number of people that get involved in a public blockchain, they tend to be more secure. They tend to be more secure because there's more people. There's more people to maintaining the same information. All right. So if I'm maintaining the same current information around between 100 people and between 10 people, if it's 10 people, I can find 10 people, manipulate them quickly. But if it's 1,000 million people, how are you gonna be able to manipulate 1,000 million people to change information? So it's more secure because there's more people maintaining that information, and it's resistant to censorship. Okay, it's resistant to being shut down. I can't even recall how many times they've banned Bitcoin in the past 20 years or whatever since it's been discovered, all right? It is censorship resistant. It is hard to shut it down. Countries have been shutting it down, and it just keeps growing because there are so many people that are involved in maintaining it, all right? So that's a public blockchain for you. If you want me to expand a little bit more on this and the incentive structure, the different types of because I've only discussed proof of work. There's many types of mining. There's proof of ownership. There's proof of like if you can prove how many coins you've got, and there's many ways of mining, not just proof of work, because blockchains are trying to move away from that because of the whole energy intensive nature of proof of work is not sustainable in the long run. Okay, I know when Satoshi created Bitcoin a long time ago, perhaps it wasn't a huge deal to mine it, but the algorithm is built in such a way that the more people are involved in the mining, because it has to keep the block time in 10 minutes, all right, the more people that mine it, the harder the mining becomes, because it has to maintain that mining, that creating of a new block in 10 minutes, so that you don't get a lot of things getting produced. Then the mining gets harder and harder technically. But then it also means that if less people mind it, the mining would get easier. I don't know. Would have to test that. But over time, it just costs more and more to mine, and it becomes unsustainable. So there's different proofs of how to to sort of participate in the chain. But that's public, right? Let's get into enterprise. So enterprise blockchains, this is like where, and they've become popular in the last couple of years as well. And I was involved in coding some of them in the past, where we're gonna say, let's say we've got a conglomerate of banks, right? Let's pick South Africa for example. Let's say we've got, like, I don't know, 10 banks in South Africa, and we want to maintain a ledger of when we transfer money between ourselves as a bank. Okay, so currently there's a system that's used for it, but imagine we wanted to move to a blockchain system, because we want to be able to build a trustless, we want to maintain the same set of data between the 10 of us, all right, without having to trust either one, but between the 10 of us, we can maintain a sort of a network like this. Okay, so this can be bank A, bank B, bank 3, bank D, or whatever, and then we maintain a ledger of every time we're transferring money between each other, and between all of us we maintain the same ledger, and we can keep the data the same. So this would be something that would constitute like a private blockchain, right? It has its applications. Honestly, I'm very open-minded. I know there's a lot of people that are like, no, but that's not really, that's just like, you guys can just keep a database and then find a way. No, it's not. It can be a blockchain, all right? And there's other applications. Supply chain, there's a lot of use cases in supply chain where you want to maintain, for example, the data of when a product goes from point A to point B to point C, and how it moved across the supply chain, and all the players within the supply chain decide to maintain a blockchain so that they can sort of like keep the ledger of the traceability or the audit trail of where the product has gone from point A to point B to point C until it reaches maybe at the point where it's sitting in front of somebody's table, right? So there are use cases for it, honestly, in my opinion, and I've seen use cases that have worked really well with using blockchain technology within a private setting where you are maintaining that information or that network. This network, you're maintaining it between only trusted individuals, right? And the difference is that not anyone can access it. So if we had a ledger between the banks, we're not going to want another person to just enter our network and start mining, okay? So there's access control, and you can even build the access control to the point where you can say, when I have even though we are all in the same network, you can have like what we call channels. Even though we're in the same network, if I'm transferring money from bank A to bank B, I don't want bank C to see what I'm transferring. Even though bank C can still be involved in maintaining the ledger, bank C does not see the individual channel communication between bank A and bank B. All right. So there's a lot of private blockchain that allow all of that to be possible. All right. It is less secure because the network is smaller, of course, and if I really wanted to mount an attack, I only have to attack 10 nodes, all right, and then I can like manipulate the blockchain, to be honest. Whereas in this case, I would have to attack 1,000,000 nodes or 1,000, 100,000 nodes, which would be much harder. Okay. It is a glorified database, yes. Okay, it is a glorified. For me, I see it as something between a database and a blockchain. All right, it definitely is more than a database, but it is definitely not a proper blockchain. It's somewhere in between, in the sense that it has the abilities of a database, but it has some capabilities of a blockchain where we are at least maintaining information between multiple nodes, as opposed to it sitting in one central place where we have to like trust this person to keep, which is what's happening now with like, credit bureaus and all of that. They are still one central place, even though they try to be independent and to be fair, but they, I only have to attack one credit bureau to attack everybody. But if banks wanted to keep credit information between themselves and use a blockchain, that would be different from a credit bureau, even though it would not be exactly the same as a full public blockchain, right? The reason why you would not want this to be public is maybe because the information that's stored in there is sensitive information, and you might not want people to be able to access it. But then again, then there's blockchains that will say, no, we can maintain a blockchain. We can have a public blockchain, but the data inside can be encrypted and you don't see it until you have a decryption key or whatever. So there's many ways around this. And you guys, if you want me to do a little bit more on enterprise blockchain, let me know. The whole purpose of this video is for me to show you the different parts of blockchain technology, and because it's a wide field, okay. And if we want to go into developing some courses in this area, what area specifically are you interested in? What area is of more interest to you to start doing courses on, because this can definitely be expanded on, right? Now, examples of public blockchains, you know them, your Bitcoins, Ethereums, IOTAs, all those things. Enterprise blockchain, what are those examples? So these are your hyperledgers, your hyperledger, your IBM blockchains, your whatever. I mean, if I go into hyperledger, for example, there was a time when I used to do hyperledger. There's a time in the past where I used to do a lot of like hyperledger, development. And I mean, there's a lot. This is I could have a whole YouTube channel just covering hyperledger. All right. There is a lot to do here. There's the different types. There is the different, like, look at all of these blockchains. So all of these are different blockchains within hyperledger. You have everything from Hyperledger Fabric, which is the one that I think I developed with the most. There it is. You have everything from Hyperledger Fabric, Sawtooth, Besu, whatever, so all of these, and they all have different use cases and different applications. For example, Hyperledger Fabric is the oldest one, the one that is, most widely used. And Hyperledger Sawtooth was developed by Intel, and it's more into Internet of Things, but it's also just like a blockchain. It works, it's just the same as Fabric, and it depends on what your use case specifically is. And you can, there are tools to build these on, and you can learn a lot more on that. So that is really the enterprise type private blockchains would be built on that. All right. Now we're going deeper into programming. Remember what I said here: when you have the specific block information, block A, block B, block A, block B, block 1, block 2, there is data that is kept inside of the block, right? This data can be transactions. This data can be anything, right? This data can be a smart contract arrangement or a record of ownership or whatever, all right? It can be kept inside of a block. So this is when we go into now digging deeper into blockchain programming and Web3, and going into now keeping specific data in the blockchain. All right. So, and specifically smart contracts. Okay. What is a smart contract? A smart contract is like a rule book, a specific blockchain or a specific arrangement that you can write the rules of a game, or the rules of the rules of engagement, and then store that inside of a block, or inside of the blockchain, as so that anybody that goes and checks that blockchain at any point will see whatever the current state of your smart contract is. So I'll give you an example. Let's say I say to you that I want to donate to you 100 Rand. I'm going to donate to you 100 Rand or $100, right? And this $100 that I donate to you, I want you to use it to start and build your company. So you are running a startup and you're asking for investments, and I decide I'm going to invest 100 Rand or $100 into your company, and you need to use that $100 to grow your company, and whatever profits you make from that, I want to get 10% of it. There are two ways you can do that. I could just give you $100 and hope you're going to do what you want to do with it. Or number two, we could just write a physical contract and say, I'm giving you this $100 for you to go and spend in your company, and then you need to pay me back 10%. If you make money, if you lose money, well, I'll know that you lost money. Or we could write a smart contract, right? A smart contract is an enforceable a contract that's going to be written in the blockchain that will govern this 100 Rand that I give you. So this 100 Rand could be now converted into Ethereum, and let's say it's equals to 1 Ether. And then I say, I'm giving you this Ether, which you can only spend doing this list of things, and when this Ether gains profitability, I have to get 10% back. I can write that into a smart contract. You understand? So I can write a contract that says, this is the Ether. This ether can only be transferable to this account, which is I'm giving it to you. After it's transferred to that account, these are the use cases of everything it can be used for. And after it has been used for that, the profits must go into account Y, and I must get paid 10% every whatever. So you can write all of that into a smart contract, deploy it into the blockchain, and then once it's deployed, then everything will be done automatically based on the rules and regulations you've written into a contract. Okay. Another thing, another way of another sort of like application of a smart contract could be like what's popular these days, ownership tokens. All right. So these smart contracts, people can develop specific tokens which they can call anything they like. All right. And within those specific tokens, they can write rules and requirements around how the tokens can be transferred, ownership of the tokens. You can have your fungible, your non-fungible tokens, where your fungible tokens is just like a Bitcoin. One Bitcoin is like another Bitcoin, and then the non-fungible ones, one Bitcoin is different from another Bitcoin because it has specific, features and ownership and everything. All right. So these are all use cases of smart contracts. You can write smart contracts to govern how. There's so many use cases. I wouldn't even be able to cover all of them here. But the important thing behind smart contracts that I want you to understand is that smart contracts are like writing, programming or writing code that governs how specific assets or specific rules behind, the movement of either Ethereum or whatever the way you're writing the contract. So if it's if you're writing it on the Ethereum blockchain, it will govern the movement of those ethers or whatever it is, or that you create your own token in there and it governs the movements of those tokens. And then you can have so many use cases and applications for those tokens, which can then govern, ownership. They can govern, rights. They can govern a lot of things. So there's a lot here. And if you guys want me to cover a little bit more on smart contract programming, let me know in the context below. Because there's a lot of blockchains that allow for this, from Solana, from Ether, there's a lot. Ether is the most popular one, but people are moving away from it now because it's getting expensive. All right. And I'll explain to you also what I mean by saying it's getting expensive. All right. So this is basically programming money. Okay. So it's the ability to program money. It's the ability to create a token within the money that you can program. How the rules of that token are going to work. All right. So this is what it is. All right. Most smart contracts are written in Solidity. It's the official programming language, but with Python, I know there's Viper that you can use, which is just a wrapper around Solidity, to be honest. And ultimately, you might as well just learn Solidity. But if you know programming, it's just the same thing. A lot of if you look at Solidity code, for example, I was looking at some remix stuff earlier on. It just works like, you can understand what it means. You've got your classes, your constructors, your variables, all of those things. And if you understand the basic object-oriented programming, you can understand Solidity very, very quickly. And we can cover this as well. And you can understand how to write your own Solidity contract, for example, from scratch, run it on a place like Remix. We can cover all of that. You let me know if that's what you want to learn. All right. Gas and transaction fees. This is the main difference between blockchain programming and normal programming. All right. Normal programming, I can write thousands and thousands, lots of code. I'm not too worried about, transaction fees because everything is being run on the server. Of course, there's some cost involved, but I pay monthly to run my server, and that's all I'm worried about. Okay. When you're talking about blockchain programming, you write code and that code is being run on the blockchain. It's not being run on your server. This code that you're going to write within your application, I'll explain this infrastructure later on, but basically that code gets run on this blockchain. All right. And for it to run on this blockchain, remember, comes the whole incentive to maintain and mine this blockchain. People are maintaining and running this blockchain, and these people are the ones who are contributing their what we call their computing power. All right. And they get paid. Okay. They get paid by transaction fees, and they get paid by mining new blocks. And the transaction fees that they get paid by is the transaction fees that you pay. All right. So you pay transaction fees to be able to run any transaction on the blockchain, and that transaction fee is the one that pays these people that are maintaining that blockchain. All right. And the transaction fees that you pay is calculated in the currency of that blockchain. So if you're running a Ethereum blockchain, the transaction fees is calculated by the ether or the gas, or they call it, yes, by the ether. So if one ether is now $1,000, you're gonna pay based on how much one ether costs. But if one ether is $10,000, right, suddenly you're paying 10 times the transaction fees. If one ether is 100, every time the price of I remember when ether was, I don't know, like $20, $200, even less than that. $100 was an ether, and we thought transaction fees were expensive, right? Now Ethereum costs a couple of thousands of dollars, and you're paying transaction fees equally. All right. So these transaction fees can get very, very expensive, and because we are dealing with cryptocurrency, that's the price is always fluid. All right, the transaction fees go up with the value of the coin, whatever it is that you're mining. That's why people are moving now away from Ethereum, and they're moving to Solana, which is supposed to have cheaper transaction fees. I haven't done any Solana programming. Perhaps you want me to do Solana programming, you can let me know, and we can cover that as well in this channel. What's relevant for you to cover, let's do that. All right. Then you got your providers and all sorts of things. So let's go into this infrastructure over here. Remember the node, right? Think of this node as this node, right? I've already covered and explained to you what is a node. All right. So you can run your own node if you want. If you've got a couple of terabytes and data and lots of money to run a node, you can. Or what most Web3 developers do, they don't run their own node. They use existing nodes that are being run by other people. Okay, there are companies out there, and I'll give you a quick example. A company like Infura, which runs and maintains nodes. Okay, and then they allow you to be able to push transactions via their node, and they charge you for it, of course, because they're also costing them money to do that. Okay, and you can build applications and use their node to access the blockchain. All right, so these are what we call the providers. All right, so these providers can be anything from Infura to, I was really trying out this new one, Alchemy is a provider as well. Okay, they maintain nodes, their own nodes, and you can access from your application the blockchain via their providers. Okay, whether it's an HTTP provider or WebSocket, but these are specific providers, right? And then you've got the library. So the web3.py library is the one, it's like sort of like the, it's the access library. It's got the code and allows you to be able to access these providers, whoever they are, and then you can write your application. So in your application, you can say, this is what I'm doing, this is my smart contract, and then you can, let's say once you've written that smart contract, you compile it, and then you say, now I want to deploy the smart contract into the Ethereum node, or into the Ethereum blockchain, so it can be stored in the Ethereum blockchain. How am I going to do this? I can either run my own node, or I'm going to use a provider over there, and then you're going to use Web3 as a library to access the provider and create a connection, and then that provider is the one that then allows you and gives you access into the node via whatever arrangement you have, whichever amount you pay. Maybe they charge you per transaction, or within Infura, for example, you can only have like up to 3 applications for free or whatever. After that you have to start paying. And these other ones, Alchemy also same thing. So that's pretty much how that works. If you want me to do a little bit more on this, let me know. So I try to cover, this whole, it's not a whole industry, but I try to show you the different aspects of blockchain programming. Everything from just understanding the basics of how blockchains work, from block numbers, hashing, the transactions, the private public keys, the transaction signatures, understanding everything from those kind of nuts and bolts of a blockchain to understanding how the peers work, what is the difference between a blockchain and a database, into public and private blockchains, understanding the differences, the pros and cons, and where you'd want to use them. That you want to cover more public stuff or more enterprise stuff, because there's a lot of growth in this enterprise blockchain industry now with, like your IBM blockchains and whatever. You want me to cover IBM blockchain programming? Do you want me to cover enterprise blockchains or more the public stuff? And then later on, then we can go into, the different types. You want me to do Ethereum, you want me to do Solana programming, all right? And once we do that, the nitty-gritty, the nuts and bolts of actually writing a decentralized application that you run yourself, and what do you want that decentralized application to do? All right, you want to create an NFT. An NFT is your non-fungible token. Nowadays, you actually don't have to run your own application to create your own NFT. There are providers out there that actually can just, you just tell them what you want your NFT to look like, all right, and then they can create an NFT for you, and you just pay them for it. Or you want to go hardcore and build your own NFT? Do you want us to do that? Let's do that instead. Or would you rather, be creative? There's so much. I mean, this is such a new area that you can be creative, and there's so much you can do. And forget NFTs, because everybody's in NFTs. Do something specific. Maybe you wanna, create an app that does something amazing in the blockchain. Let us know. Let's build it. And use the providers and Web3 to get it to work. So whichever one it is, let me know, guys. I'm open to your comments. I will compile all the comments if I get any. If I don't get any comments, maybe we'll just go back to doing Django web development. It will depend, all right? So let me know, and I will see you guys next week. And I'll give you I'll go through the feedback that I get. And then, maybe what I do next week will be based on your guys' feedback, all right? So thank you guys for watching, and we'll see you again next week.